Start recording this. I never did.
Okay. Sorry, Adam, you missed a little bit about how it is. We're starting to, for the video, we're starting to make the unit circle here, and we just started off with the bare minimum, the 4 cardinal locations, okay? What the XY coordinate is at those locations, and what the angle is at those locations, okay? What we're going to do now is we're going to fill in the rest of the circle and figure out how to do that. We're to start in the first quadrant, okay? Before I go any further and just start labeling points up here, it's good to understand where these values are going to come from. And they're going to come from special right triangles. Specifically, 2 special right triangles. The first one is the 30, 60, 90 triangle. Okay? 90. Okay? Which, if you remember from geometry, is a 1 root 3, 2. Okay, so the sides are in ratio 1, root 3, and 2. Okay? If I was to do this in radians, this angle here, the one that's 30, would be pi over 6. Okay, pi over 6 and 30 are the same measure. Okay? The one that's 60 is pi over 3. Okay? Would be its measurement here. Okay? Now, the thing though is, with this 30, 60, 90 triangle, the hypotenuse is what? 2. What do we want the hypotenuse to be if we're doing it via the 1. So what I have to do is, I have to reduce the, basically, using properties of similar triangles, I have to reduce this down so its hypotenuse is 1. It's actually not as hard as it seems. I would just divide every side by 2. Okay? So if I did that, this becomes 2 over 2, which is 1. This becomes 1/2, and this becomes 3/2. Not 3/3, 3/2. Okay? Easy enough, right? No problems there. Okay? So, if I were to write, I can write 2 locations now on my unit circle and know what the angle is and what the XY values are. Yeah. If my angle is pi over 6, which is going to be about right there, okay, that's a pi over 6 angle, okay? The XY coordinates are going to be, the X coordinates can be root 3 over 2, and the Y coordinate's going to be 1/2, okay? And so this is at pi over 6, or 30 degrees. That's how we get that one, okay? If I wanted to, one thing I could do with this rectangle, one thing I could do with this triangle is rotate it so I'm looking at pi over 3 as the main angle, right? Then X and Y just flip, don't they? Yeah. So I also get 60 degrees up here, okay? This location right here would be 1/2 root 3 over 2, and corresponding location pi over 3, or 60 degrees, okay? And this guy's going to have to move, because he's getting in the way. It's going to make me move everything here. Yes. The answer is yes. Okay? So, that fills in, 2 of those 3 locations I said were special there. This came from a special right triangle we have seen. Okay? Now, the next special right triangle we're going to deal with, okay, that we have known angles for, is the 45, 45, 90 triangle. Okay? Or a 1, 1, root 2 triangle. You remember that one from geometry. Okay? No, let's do it better. One more time here. Okay. There we go, that looks a little better. Okay. Sweet. Alright. So 1, 1, root 2 are the sides. That's the 90-degree angle. And this one has the benefit that each of these angles is 45 degrees. Okay? Or pi over 4. Okay? Okay? When you write it in radians. Okay? Now, again, what's the hypotenuse of that triangle? Square root of 2. What do we want it to be?
1.
So what am I going to do to each side? Divide by root 2 over 2. Okay? Okay? Now, what you're going to do here, unfortunately, we don't like having radicals
Wait, what if
in.
you multiplied by?
Huh?
No. Yeah, what if you multiplied by root 2? Do you do
There
that?
goes 2. And
Then I have 2, and so I still have to add. So
Oh, you
Yeah,
want to get
divide
1.
by
sorry.
we want to get 1, but that's okay because what we're going to end up doing that anyway because these guys right here had that radical in the bottom. We don't want a radical in the bottom, so we have to rationalize it, which means we multiply it by root 2 over 2. Okay, so we do that to get the answer as root 2 over 2, like so. Okay, so this is also root 2 over 2. Okay, so that means,
Wait, shouldn't that be? Yeah.
okay,
Yeah.
so that means if I'm at the location where 45 degrees or pi over 4 is, which is right here, okay, my xy coordinate is root 2 divided by 2, root 2 divided by 2. It's where x and y are equal on the circle, okay? And this happens at pi over 4 or 45 degrees, okay? And that fills in the first quadrant of the unit circle with known values, okay? That's where you find them, that's what their values are, etc., okay? Any problems there? They all came from special right triangles and the known angles we have for those, okay?
Where'd you pull the triangles from?
It's geometry, it's special, the original special right triangles.
Okay.
It's,
So we need to know all those then. too, right?
actually, at this point, not really. It's just
Yeah.
more of how I got those numbers there. Because I could have just written the numbers up there and then someone's going to ask me, well, how do I know that?
Yeah.
Well, how do I know that? From these triangles right here.
So
Okay.
we just have to memorize the numbers, right?
Yeah.
Okay.
You
Okay.
should by now, though, know your special right triangles because they come up on the SAT test and the ACT.
Yeah, that's what I know.
So you might want to review them if you're having trouble with those. Okay.
Yeah.
Yeah, it's one of the downsides of teaching geometry in the 9th grade is you learn all this in the 9th grade and then probably forget it your 10th grade year and never expect to remember it in the 11th grade when you did the SAT. It's really unfortunate.
So do we add pi over
Okay.
2 to everything else?
Okay. Huh?
Do we add pi over 2 to next quadrant?
Ah!
No?
So you figured out how to figure out the
Oh,
next quadrant here.
Oh, wow.
Okay. If I wanted the values in this quadrant right here, okay, for the angles, all I do is add pi over 2 to each of these in succession. So this first one right here, the angle is going to be pi over 2 plus pi over 6. Pi over 6 was the first one. This would be my first one in this quadrant, okay? So I'd add pi over 2 to it to get that location. Pi over 6 plus pi over 2 is 4 pi over 3, okay? So that's 4 pi over 3, or if I'm doing it in degrees, it's 90 degrees plus 30 degrees, so it's 120 degrees, okay? The second angle here would be pi over 2 plus pi over 4, which is 3 pi over 4, or 90 plus 45, so 135 degrees, okay? This last one down here, pi over 2 plus pi over 3, it ends up being 5 pi over 6, and then again it's 90 plus 60, so it's 150 degrees, okay?
Why, for the first quadrant, what is it? Or for the first dot, for 120 degrees, 4 pi over 3?
4 pi over 3, yeah.
It looks as 2 pi over 3.
Oh, yes, it's
4 pi
absolutely
over
right. It should be 2 pi over 3. Excuse me, I miswrote it. You're right, I'm wrong. Good for double checking. Yeah, that's good. Good eye. 4 pi over 3, that makes sense. 4 pi over 3 is over 1 pi and right part, done. Okay. Now, that gives me the angles there. I was able to figure out all those angles by just adding pi over 2 to what was in the quadrant beforehand. Okay? Which makes life easy, right? Now, what do I do about, though, the coordinates, the xy coordinates?
Add 1. What?
Well, not add 1,
Make the x negative.
make the x's negative. It's going to be the same exact numbers as these, but x is going to be negative over in this quadrant, right? So this one right here would just be minus 1/2 root 3 over 2. This one would be minus root 2 over 2, root 2 over 2.
Okay, watch this.
And this one down here would be minus root 3 over 2, 1/2. So notice I just took, to get this quadrant, I just essentially mirrored these numbers across and just negated their x-coordinates, okay? Same exact number. So notice I don't have to memorize a bunch of new numbers.
Just those.
If I just know these right here,
That's actually good.
I can figure out those immediately because I just know, hey, in the second quadrant, x is negative. Numbers should be exactly the same, x should just be negative though, okay? Another hint to remember this as well, notice this point and this point are where pi is over 3, okay? These two down here is where pi is over 6, okay? So the ones closest to the y-axis are where pi is 3, over 3. The ones closest to the x-axis is where pi is over 6. And the one in the center is always where it's pi over 4. Okay? Again, another little trick to memorize, to remember how these things work. Okay? Again, all figured out if I know this first quadrant down.
So that would work for the.
It's absolutely going to work for the quadrants down here as well. Okay? If I fill in this quadrant right here, the first angle, if I want to figure out numerically, it's pi plus pi over 6, okay? Or 7 pi over 6. Kind of running out of room here. Stupid. Okay. This is pi dash 180. Okay, so this one right here would be 7 pi over 6, or 180 plus 30 degrees, so what, 210. Okay? And its xy coordinates, okay, going to be the same as this one right here, except now both x and y are negative.
Oh,
Okay.
this is not that hard.
Yes, it really is not that bad.
Carl, it just clicked. Say that. This isn't that hard.
Okay?
It's just like a graph,
Right here,
a circle.
okay, again,
Oh, it's
going to be
it's
some version of pi over 4, right?
negative root 2 over 2.
Going to be negative root 2, negative root 2 over 2, negative root 2 over 2. You're right about the coordinates. The angle, though, how would I figure it out?
You 5.
Pi fourths plus
Pi over 4.
pi, right?
Yeah,
Pi over 4 plus pi, which is 5 pi over 4. Okay?
That's a goal.
Actually, fairly, yeah, and actually, you're going to note here another, you're going to see here very quickly another pattern develop. Pi over 4, 3 pi over 4, 5 pi over 4. So what should this one be over here? 7 pi over 4. 1, 3, 5, 7.
Oh, yeah.
Okay?
And what are those numbers telling
That's the angle.
you? Okay. that's
Okay.
fine.
So the coordinate location, as was said, is 2 over 2 over 2 minus root 2 over 2. The angle is 5 pi over 4, or 180 plus 45, which is 225. Yeah, the degrees are actually the hard part of this because they don't follow a nice pattern. They just keep going up, and so you have to kind of memorize.
So we have to put the degrees in there.
For some of them, you'll you do need to know both the circle and radians and degrees. Okay, but nice thing though is you can figure out if you know these, you're just adding these numbers to 90, 180, or 270. So, and that addition is not hard to do. I mean, like, what's 30 plus 270? It's 300. You can't do that. You probably shouldn't be.
Wait, what are we adding? What did you just say?
To figure out the degrees, you do the same things you do with the radians. You just add the degree you're at, the first one, to whatever the head of the quadrant is to get to the next location. That's how I figured out. That's 120, 90 plus 30. Okay. This one's 135, this is 90 plus 45. 150, 90 plus 60. 210, 180 plus 30. 225, 45 plus 30. So we can come in here and fill in this. This one's 4 pi over 3, or 180 plus 60, which is what, 240? Okay? And it's degree, it's the coordinates, 1/2, root 3 over, negative 1/2, negative root 3 over 2.
I know it, Carl.
Awesome.
Okay? And again, we can actually go ahead using the same method, fill out that last one down here, and it should work out fine, okay? Because we're out of time, you guys are itchy to get to your grilled cheese sandwiches. LD, you should be able to figure this out at this point. Okay?
Thank you, sir.
You're welcome. That's how you make a unit circle. Memorize it for Saturday.
What gets the room?